Welcome all my dear students to Sudharma's Physics classroom. Today we are going to discuss the let us assess part from the chapter Refraction of Light. So it's chapter 5 from our SSLC textbook. Already the chapter discussion is completely done. So this is a text back exercise. And I'm very sure you are all relieved after seeing the reduced syllabus by SERT. So from this chapter, there are some major changes in the focus point. So the lens formula and the numerical and the atmospheric refraction, it's not included in the syllabus for 2021 exam. That's 2021 academic year. Because of the COVID pandemic, the syllabus is reduced. So you don't have to this year batch. You don't have to focus on the lens formula and the numerical part, but the ray diagrams are included in the syllabus. Total internal reflection is there in the syllabus. So the major change happened especially in the chapter Refraction of Light. But in today's class, I will be discussing all the questions of the text back exercises. That's from the let us assess part, because those who wants to study, see, if you want to learn extra, if you are not bothering about the syllabus, okay, you can go ahead and do all the questions, but for exam the lens formula will not come. But since I'm making a video, it will be useful for the students who comes later on also, right? Maybe for the next year also the video will be useful for them, so that time this content will be there in the syllabus. So I'm stressing lens formula, numericals are not there. Then atmospheric refraction, that means the twinkling of stars and all those things are not there. But whatever other things, all the other things, including the ray diagrams and the image characteristics of the lens, it is included in the syllabus. Okay, so now let's start with the questions. Refractive indices of different materials are given. Find out the medium through which light passes with maximum speed. So how do we answer that? We have a set of materials, the medias, and the refractive indices are given. Glass 1.52, glycerin 1.47, sunflower oil 1.47, water 1.33, and flint glass 1.62. So the question is, find out the medium through which the light passes with maximum speed. So among the materials given here, how do we find out in which the light passes with maximum speed? We know that absolute refractive index, it is inversely proportional to the speed of light. That means the medium which is having the maximum refractive index, the speed will be the least. But the question is this maximum speed. So when we have to get maximum speed, the material should have very less refractive index. So from the given table, we can see that water has the lowest refractive index. So it has the maximum speed. See, we know that light travels the fastest in air or vacuum. That is 3 into 10 power meter per second. That is the speed of light in vacuum. But in the question, air or vacuum is not given. But among the materials given, the lowest refractive index is for water. So we can choose the answer as water. And if you are asked for justification of your answer, you can write refractive index is inversely proportional to the speed of light. Moving on to the second question. The nature of images formed by two lenses are given. An erect and magnified virtual image, an erect and diminished virtual image. What type of lens is used in each case? By using which type of lens, which will we get? By using which type of lens will we get an image having the same size as the object? What is the position of the object? So let's answer the first part. So there are two situations, 1 and 2. So we have to think now. The nature of images formed by two lenses are given. So the nature is given. The first case is an erect and magnified virtual image. Erect, magnified virtual image. Which lens gives you an erect, magnified virtual image? Definitely it is a convex lens. Why convex lens? Because when the object is between optic center and the focus, we will be getting a magnified virtual erect image. Second one, an erect and diminished virtual image, definitely it is given by the concave lens. My dear students, this is included in the syllabus as per the focus point. Don't think that the complete lens part is eliminated. No, lens, ray diagrams and its image formation and its characteristics are included in the syllabus. It is in the syllabus. It is not eliminated. Only the lens formula and the numerical and atmospheric refraction is not there in the focus point. Okay. So this is there in our syllabus for this year. So make sure you learn how to answer this. So erect, diminished virtual image. Diminished virtual image is given by concave lens and magnified virtual image is given by convex lens. Now, question B. By using which type of lens will we get an image having the same size as the object? What is the position of the object? So, hope you got the answer for this. Keep your answer in your mind and check whether it is matching with my answer. So we need the same size image as the object. So definitely we are going to get this by using a convex lens. Which position? I told you when I was teaching the ray diagrams, I told you we need to be very thorough with the object positions and the characteristics. So those who practice the ray diagrams will be able to answer this immediately. Convex lens, when the object is at 2f, we will be able to get the same size image as the object. And image will be at 2f on the other side of the lens. So what is the position of the object? Object is at 2f. Hope you understood the answer. Now moving on to the next question, question number 3. So here we have Mn represent a lens. What type of lens is this? How do you understand what type of lens it is? It is going to be a convex lens because we know that from the object, a ray of light comes and hits the lens. After hitting the lens, it is bending to the other side. Right? It is converging to a point. It is converging to a point. Converging lens is convex lens. So the answer is convex lens. If it is shown as a diverging one, diverging ray, then it is going to be a concave lens. But here it is converging to the focus. So this is a convex lens. Now, what are the characteristics of the image? So how do you know what are the characteristics of the image? So here we have to make sure to identify the position of the object. Object is between f and 2f. When the object is between f and 2f, we know that image will be between, when the object is between f and 2f, image will be beyond 2f. Image is beyond 2f. It is real and magnified. It's real and magnified. So here you are expected to draw the ray diagram of the object between f and 2f. You are going to draw the ray diagram by using, see already one ray is given. So copy the ray diagrams in the science diary and complete it. How you are going to complete it? All the things are given here. Now you just have to draw a ray which passes through the optical center. When it passes through the optical center, what happens? When it passes through the optical center, then it will be meeting beyond 2f. So let me just use a straight line which passes. So here on the diagram, I'm just using the same diagram. So you have to copy it. Okay. So I will have to extend this ray because the other ray which is given in the question, right? The ray which is given in the question, I will have to extend it little more and it is coming along with the answers I have written. So you are going to copy it. Okay, so you're going to copy it and complete the diagram. So here, somewhere here, it will be meeting, right? So this is the position it meets. So here you will be getting the image. So this is going to be a bigger image. Okay, it's going to be a bigger image forming there. So a magnified image. So I just gave you the hint what to do. So you have to just copy the same diagram and draw a ray which passes through the optic center of the convex lens. So you will be getting the image beyond 2f and it is going to be magnified. Okay, it's a magnified and real image. So this is how we are going to copy the diagram and complete it. Now, the fourth question. What do you mean by the power of a lens? What is the SI unit of power of a lens? Calculate the power of a concave lens of focal length 25 centimeter. So this year, student, as you say, Corona batch students, right? Corona batch students, power is not there in the syllabus. But I'm just giving you the explanation for those who want to understand this, who is interested in doing this. But for exam, it will not come this year. Only for 2021 batch, this part will not come as the syllabus is reduced. Because there is a lot of confusion between the students, what is there in the syllabus, what is not there in the syllabus. That is why when it comes to the question, I am explaining again. Okay, so what do you mean by power of a lens? Power is the reciprocal of focal length expressed in meter. What is the SI unit of the power of a lens? SI unit of power of lens is diopter. So 1 diopter means it's a power of a lens whose focal length is 1 meter. Now, calculate the power of a concave lens of focal length 25 centimeter. So, as per the Cartesian sign convention, we know that focal length of a concave lens is negative minus 25 centimeter. So, minus 25 centimeter, convert it into meter. So, minus 25 divided by 100 meters. Now, power P is equal to reciprocal of focal length expressed in meters. So, 1 by minus 25 by 100. So what happens here now? This 100 goes to the numerator. I am just taking the negative sign along with that. So minus 100 divided by 25. So this is equal to minus 4 diopters. So remember to put the sign because it's a concave lens. Concave lens has a negative power and it has a negative focal length. Now, some of you have a question in your mind. Why I have taken 25 by 100 as it is? Why didn't I put it as, I didn't reduce anything there. I didn't put it as 0.25, right? A lot of questions are there in your mind. So this is the best method to calculate the power. I feel it is very convenient because we are going to divide 100 by 25. What if I am putting 0.25? So you will be getting the value as 1 by 0.25. Then most of you will get stuck there how to solve that 1 by 0.25. It's difficult. Again, you will have to remove that decimal points, then do the calculation. So this is better way. And most of the students find this method very easy. That is why I have shown this method here. So I'm not going to convert it into fraction. I'm not going to convert into decimal. Just I'm not going to simplify this. Just keep as it is because dividing 125, right? 100 by 25, that's very easy. It's minus 4. Okay, so minus 100 by 25 minus 4 diopter. Next one, it is in the syllabus. Very important. Observe the figure, light falling on two different media are shown. And which medium has greater optical density? Why? Which medium has greater refractive index? So, when you analyze this two diagrams, this is really important and it's a very tricky question. So, we have two diagrams given. The first thing you can observe is in both the diagrams, the angle of incidence is the same. I is equal to 40 degree. And coming from air to medium 1, air to medium 2. So another analysis here, the comparison, when we do the comparison, in both the diagrams, the light, incident light is coming from air to another medium. Okay. Now, the difference is only in the angle of refraction. In medium 1, R is equal to 20 degree and in medium 2, R is equal to 30 degree. So the question is, which medium has greater optical density? Optical density and refractive index. So it's the same way to express a medium. So optical density is expressed in terms of refractive index. More the refractive index, more optical density. That is what we can understand. For example, glass has refractive index of 1.5 and water has refractive index of 1.33. So the optical density of glass is greater than the optical density of water. So that is the way we explain and relate optical density and refractive index. Now, how do we decide medium 1 or medium 2? So, more the refractive index, more bending will take place. More bending will take place means we know that when light travels from rarer to denser medium, the light will be bending towards the normal. The more denser the medium, the more bending will take place. More bending towards the normal. So here the angle of refraction, more bending is taking place. Okay. So medium 1 and medium 2, when you observe, even if you observe the diagrams, you can see bending, more bending took place for the medium 1 and less bending happened for medium in medium 2. So more bending in the sense angle of refraction will be less in a denser, when more dense medium comparatively. These two medias are denser medium compared to air, but among medium 1 and medium 2, which one has greater optical density? The answer is medium 1. For answer for me question A and question B, it is medium 1, because when we say greater optical density, that indicates greater refractive index. So the answer for Y is the angle of refraction. The bending is more in the case of medium 1. More bending towards the normal, or less angle of refraction is in case 1, in medium 1. So the medium 1 is denser than medium 2. So refractive index of medium 1 is greater than refractive index of medium 2. This is how we answer this question logically. Because there is no refractive index given, just the angle of refraction are given here. Moving on to the sixth question. Again, 2021 batch, lens formula numerical is not there, but I'm going to solve it for those who need to learn this. Okay. An object of height 3 cm is placed in front of a convex lens of focal length 20 cm at a distance of 30 cm. What is the distance to the image formed? An object of height 3 cm is placed in front of a convex lens of focal length 20 cm. So height of the object is given 3 cm. It's a convex lens, so focal length is positive, plus 20. At a distance of 30 cm, an object of height is placed in front of a convex lens of focal length 20 cm at a distance of 30 cm. That means object distance is minus 30 cm. Object distance is always negative. What is the distance to the image formed? That means we are expected to find out the image distance. So we have the lens formula. So I'm going to answer the first question. Lens formula is 1 by f is equal to 1 by v minus 1 by u. So we have to calculate 1 by v. 1 by v is equal to 1 by f plus 1 by u. Now substitute the values with proper sign. 1 by f is 1 by 20 plus 1 by minus 30. So it's going to be 1 by v is equal to 1 by 20 minus 1 by 30. So here LCM is 60. So 3 minus 2, it's going to be 1 by 60. 1 by V is equal to 1 by 60, or V is equal to 60 centimeter. So I'm getting a positive value for image distance. So definitely I can say that when I'm getting a positive value, this is plus. Automatically I got the value as positive. So when I get the image distance positive, it is going to be a real image. All the real images are inverted. Okay, all the real images will be inverted. Now question C. What is the height of the image? To calculate the height of the image, we need the magnification. So magnification M is equal to V divided by U. So what is V? V is equal to 60, U is equal to minus 30. So this is going to be minus 2. So now let's see the value minus 2. Minus 2 means it is real. So all the real images are inverted. Now the question is whether it is diminished or magnified. The number is greater than 1. 2 is greater than 1. So this is magnified. So we can write magnified. This is again a magnified image. But the question here is what is the height of the image? Magnification, we have another formula. M is equal to height of the image by height of the object. So height of the image is equal to magnification into height of the object. Minus 2 into height of the object is 3. So we are going to get the answer as minus 6 centimeters. So this is the height of the image. Okay, so it is a real inverted magnified image. Question number 7. In the table, the absolute refractive indices of certain transparent media are given. So from there, we have to answer certain questions. Find out from the table the medium of highest and lowest optical densities. If the speed of light in air is 3 into 10 power 8 meter per second, what will be the speed of light through kerosene? Will the ray of light deviate towards the normal or away from the normal when it enters from air to diamond obliquely? And D, the refractive index of diamond is 2.42. What do you mean by this? Calculate the speed of light through diamond. So let's first answer question A. Find out from the table the medium of highest and lowest optical densities. So highest and lowest optical densities. Optical densities related with refractive index, the material which is having the highest refractive index. From the table, we can see the refractive index of diamond is 2.42. So this is having the highest optical density, that is diamond. Now, lowest optical density, or the one which is having the lowest refractive index in the table, that is nothing but air. If vacuum or air is given, it's having the lowest refractive index or lowest optical density. Now question B. If the speed of light in air is 3 into 10 power 8 meter per second, that means C is equal to 3 into 10 power 8 meter per second. What will be the speed of light through kerosene? We know that refractive index mu, absolute refractive index, is equal to C divided by V. So mu for kerosene is given as 1.44. That means 1.44 is equal to 3 into 10 power 8 divided by V, or V is equal to 3 into 10 power 8 divided by 1.44. This is going to be the speed of light through kerosene. Once you calculate the value, you will be getting the answer as 2.0833. Up to 2 decimal is enough. I'm just writing it into 10 power 8 meter per second. So speed of light through kerosene is 2.08333 into 10 power 8 meter per second. So this is the method to calculate it. It is a direct question. This is there in the syllabus. Question C. Will a ray of light deviate towards the normal or away from the normal when it enters from air to diamond obliquely? So air refractive index is 1.003 and diamond refractive index is 2.42. So what does it mean? The ray is traveling from rarer to denser medium. So what happens to the ray which travels from rarer to denser medium? It will be bends towards the normal. Now, you will be wondering what do you mean by this oblique incidence at an angle which is less than 90 degree. Because if it is incident perpendicular to the surface, what happens? It passes without any deviation, right? We won't be able to see the bending of light. It just transmits the light if it is normal incidence. Okay, so here when light travels from air to diamond, it is traveling from rarer to denser medium, so it will be bending towards the normal. Now question D. The refractive index of diamond is 2.42. What do you mean by this? Calculate the speed of light through diamond. So refractive index mu is equal to 2.42. This is very similar to our question B. So here refractive index of diamond is given. What do you mean by this? What do you mean by the statement? So we know that mu is equal to C by V, or that means C is equal to mu into V. So in this case, C is equal to 2.42 times the speed of light in diamond. So the light travels 2.42 times faster than in diamond. That is the meaning of it. Now calculate the speed of light through diamond. So how do you calculate the speed of light through diamond? V is equal to C by mu. C is 3 into 10 power 8 and mu is 2.42. So we'll be getting the answer as 1.2396, or approximately we can write 1.24. This is the speed of light into 10 power 8 is there. Okay, 1.24 into 10 power 8 meter per second. That is the answer. So the diamond has the highest refractive index, and the light will travel with the least speed through diamond. That's another important question. So only the lens numericals are not there, and only one or two numericals were there in this let us assess part. Okay, so all the things discussed today, it is very, very important. Now moving on to the extended activities, there are 3 questions. Normally, even if we don't do the extended activities, it's fine. But here there are some important tricky questions in this chapter. That is why I thought of doing the extended activities also. So it can come as a higher order thinking level questions. Okay. There are 3 questions. Half portion of a convex lens is wrapped with a black paper. Can this lens give a complete real image of an object? Explain. So we are going to cover the convex lens like this, the way it is shown in figure. So the question is, can this lens give a complete real image of an object? Definitely it can give. It can give a real image, a complete real image. You will be thinking only half the image will be formed, right? No. So you think like that because when we draw the ray diagrams, we use only 2 or 3 rays to form the image. But those rays we are taking for our convenience. Okay. We can draw in any ray which passes through any point of the lens. There is no problem in drawing through any part of the lens. So we can draw any ray. It can pass through the bottom part of the lens also. We have not practiced the ray diagram for that, but it can pass through the bottom part. That means the uncovered part of the lens. A real image, complete real image will be formed. But the problem is their intensity, the brightness will be less. Okay, but the question is, can this lens give a complete real image of an object? Yes, it can give, because the light passes through the uncovered portion of the lens and it forms an image, but the brightness will be less because the light is not completely it's not passing completely through the lens. It passes only through half portion of the lens. So the intensity of the image, the brightness of the image formed will be less compared to the image formed by the complete lens. That is the answer for that. Hope it is clear for you. Then question number 2 in the extended activities. The refractive indices of different media are given. Analyze the table and answer the following. So medium 1 and medium and refractive index are given. In which medium will light travels? Light has the highest speed. And when we have to calculate the highest speed medium, we know that refractive index is inversely proportional to speed. So when the speed is highest, refractive index will be least. So this is very similar to our first question. In which medium will it have highest speed? And in this table, it will be with traveling with highest speed in water, because all the other materials have the little more higher refractive index. Higher the refractive index, less the speed. Okay. Now, Glycerin, water and sunflower oil are taken in 2 beakers. A glass rod is dipped in one and a Pyrex glass rod is dipped in the other. So the diagrams are shown. Do they appear in the same way? In which media are they visible? Justify. So a glass rod is dipped in one and a Pyrex glass rod is dipped in the other. So what are the materials, the liquids taken? Glycerin, water and sunflower oil. So we have to check the refractive index. So glycerin, it has 1.47. Water has 1.33. Sunflower oil has 1.47. And Pyrex glass has 1.47. So these three materials are having the same refractive index. So when we combine these media, when light passes from one medium to another, which is having the same refractive index, we will not be able to see the bending of light. Okay, refraction will not be there because it's having the same refractive index. So the question is, we are going to dip glass rod. Okay, we are going to dip glass rod in glycerin, water and sunflower oil. So what is the glass rod? It can be crown glass or flint glass, whatever it is. Its refractive index is different. So do they appear in the same way? So in glycerin and in sunflower oil, if a glass rod is dipped, see it, everything is taken in the same beaker. Okay, all the three liquids are taken in the same beaker and the glass rod is dipped. So when it is dipped wherever the portion of water is there, we will be able to see that. Wherever the the glycerin and sunflower oil, in glycerin and sunflower oil, the way it bends, that will be the same because it has the same refractive index. In water, it has less, water has less refractive index compared to glycerin and sunflower oil. So the bending will be less in water. So the extent of bending will be different. We will be able to see the glass rod. Now comes the next interesting thing. A Pyrex glass rod is dipped. Pyrex glass rod has the same refractive index as sunflower oil and glycerin. So the portion where sunflower oil and glycerin is there, we will not be able to see Pyrex glass. But wherever water is there, we will be able to see that because water and Pyrex glass rod has different refractive index. So we will be seeing the image of that. We will be seeing the bent portion of the glass rod, Pyrex glass rod. But in sunflower oil and in glycerin, we will not be able to see that because sunflower oil, Pyrex glass and glycerin has the same refractive index. Hope the answer is clear for you. Now going to the last question of the extended activities. Take a clean mineral water bottle and fill it with water. Put a hole on one side of the bottle. Allow water to flow out while passing a laser ray through it. What do you observe and why? So let's observe the diagram carefully here. Laser rays are allowed to pass through water. Then water, when you put a hole at one portion of this bottle, water starts flowing, right? And you can see that water is trapped in that water, the light is trapped in the water which is coming out of this. So what does it mean? We are not seeing a bending of light from water to air. That means that it is satisfying the condition for total internal reflection. Okay, it is satisfying the condition for total internal reflection. So it's multiple times it is internally reflected within water itself. When it is trying to come out of water, since it is satisfying the critical angle condition, because light is trying to come out from water to air, that is from a denser medium to rarer medium, we are not able to see refraction here. We are seeing the light is trapped within that water itself. That means total internal reflection is taking place. That is the observation we can have from this experiment. So hope all of you have understood the answers for all these questions. So learn very clearly all these questions, very, very important, very tricky questions. Read the textbook and then practice the questions. Okay. So in the next class, we will be starting the next chapter, that is vision and the world of colors. So the letters SS part for the Malayalam medium students, the complete Malayalam version I will be doing as a separate video because the question and the terms, it's different. Okay, so that is why I'm doing separate classes for English medium and Malayalam medium students. Pure Malayalam, complete Malayalam classes are there on a separate video. Separate playlist is there for the Malayalam medium classes. Okay, so Malayalam medium students can go and watch that. So, vision and the world of colors again, some portions are deleted for this year. So, I will be explaining what is there and what is not there when I start the class for that chapter. Okay, so learn the complete chapter, refraction of light, do the practice of the text back exercises. And if you are new to the channel, please subscribe to the channel and click the bell icon for updates on the classes. And see you soon with the next chapter. Thank you for watching. Bye.